Now let's focus more on a detailed view of services used in OICP. In this part of the training session, we will cover eRoaming authorization, eRoaming reservation, eRoaming EVSE data, eRoaming EVSE status, eRoaming dynamic pricing, and eRoaming charging notification services. Most of those services have similar flow and logic for both CPO and EMP roles, but in this module we will cover them from CPO perspective. Then we will change perspective to EMP, go through them once again, and see the differences. Let's get started. eRoaming Authorization Service. First operation in eRoaming Authorization Service is eRoamingAuthorizeStart. This operation is used for authorizing charging process in Hubject platform. Implementation is mandatory by every CPO partner. In general, this message is used when user authenticates himself at a charging point by, for example, RFID card. Auth request comes from CPO to Hubject platform, and then eventually it goes to EMP. Every request must contain operator ID and type of identification data. As a result, you may expect generated session ID for charging process. Authentication process is not so simple. We may have three different scenarios. At first, Hubject will try to authorize the request in offline mode. In other words, it will check its database for the customer token present in request and validate if it can start a charging session. If that's true, it will automatically return positive response to CPO without any involvement of EMP. Authentication data needed for that can be uploaded by EMP beforehand using eRoaming Authentication Data Service dedicated only for EMPs. In case offline authorization is not possible, Hubject will try to communicate with EMP directly. ev-cpo ID, present in identification data, will be used for identifying involved EMP. If Hubject finds EMP, then it will forward the request to him. Of course, with some conditions. Given EMP must implement authorization service for online EMP. The response must contain provider ID and also may contain a list of identification data that can be used for stopping a charging session. For example, it can be QR code or RFID card. If for some reason Hubject cannot identify EMP based on identification data, it will try to authorize the request in another way. At first, it will fetch all the EMPs that are under a contract with CPO. In other words, it will fetch all the EMPs that subscribe to CPO authorization service. Then it will forward the request to all of those EMPs and wait for a result. This process is called broadcasting. After every EMP responds to the request, Hubject will check if only one response was positive. If that's true, the charging process can be started and provider ID is known. If not, then this operation cannot be authorized. Here we have an example how eRoamingAuthorizeStart request looks like. CPO partner session ID and EMP partner session ID are optional, but can be used for custom session mechanism. eVSE ID is also optional because it can be derived based on identification data. Nonetheless, it's recommended to provide it as well for better debugging. Identification is used for specifying authentication data to authorize the user. Identification type can be RFID, QR code, plug and charge, and remote. Operator ID is mandatory and it identifies the CPO. Pricing product ID is a name of pricing product for tariff identification. The last one, session ID, identifies the process and it also can be optional. eRoamingAuthorizationStart message is used as a response for eRoamingAuthorizeStart request. This message is very similar to acknowledgement, but has some additional fields. The first one is authorization status, which specifies whether the user was authorized to charge or not. The next one is authorization stop identifications, which is a list of identification data that can be used for stopping the charging process. The last one, provider ID, specifies involved EMP. The next operation to perform in authorized service is eRoamingAuthorizeStop. Basically, AuthorizeStop is almost the same as AuthorizeStart, but of course it's used for stopping the charging process. Session ID must be provided because based on that, Hubject can derive EMP data used for authorizing charging process. Also, it will allow Hubject to try to stop the charging process in offline mode. The request for eRoamingAuthorizeStop is very simple and looks similar to AuthorizeStart. Worth remembering is that ev-cpo ID is again optional because it can be derived based on session ID. Nonetheless, it's also recommended to provide that for better debugging. eRoamingAuthorizationStop is a response for eRoamingAuthorizeStop request. This message is very similar to acknowledgement and also almost the same as eRoamingAuthorizationStart message. The only difference between those two is that eRoamingAuthorizationStop message does not include AuthorizationStop identifications field. eRoamingAuthorizeRemoteStart is another AuthorizeStart operation in authorization service, but this time the request comes from EMP to CPO. It allows EMP customers to directly start a charging process with, for example, mobile application. Implementation is mandatory by CPO because it must be able to accept and process authorized remote start messages. Request must contain provider ID and ev-cpo ID. Logic for authorized remote start is a little bit different than for authorized start. At first, Hubject will check if there is a valid contract between CPO and EMP, based on provided ev-cpo ID. Then it will check if ev-cpo ID is among the data uploaded by CPO. If that's not true, then the status code 603 on a known ev-cpo ID will be returned. Also, ev-cpo with given ID should be Hubject compatible. Otherwise, status code 604 will be returned. If ev-cpo ID is Hubject compatible, or CPO has not uploaded any ev-cpo records yet, we cannot tell for sure that given CPO is or isn't the owner of given ev-cpo. In that case, Hubject will generate session ID and forward the request to CPO. CPO must return an acknowledgement with information whether he is the owner of ev-cpo and if charging process can be started or not. Based on this example, we can easily tell that eRoamingAuthorizeRemoteStart request does not differ much from eRoamingAuthorizeStart request. The only difference between those two is previously mentioned ev-cpo ID and provider ID. eRoamingAcknowledgement message is a response for eRoamingAuthorizeRemoteStart request. It is also a response for most of the services we will cover later in this course. Structure is very simple. Session ID related fields are the same as we have covered in eRoamingAuthorizationStart and eRoamingAuthorizationStop messages. The only difference is result field, which indicates whether operation was performed successfully or not. Of course, there must be eRoamingAuthorizeRemoteStop operation. It allows EMP customers to directly stop a charging session. Again, implementation is mandatory by CPO partner because it must be able to process this message in order to stop existing charging session. As you can see on example, the request is very simple. You need to provide ev-cpo ID, session ID, and provider ID. As a response, you may expect acknowledgement message. After a charging session is completed, CPO must generate charge detail record associated with session ID. A CDR is a final summary of a charging session with details like meter values and consumed energy. CDR is immutable. You can think of it as a kind of an invoice for a charging session. Because of that, Hubject created a separate operation in authorization service called eRoamingChargeDetailRecord. This operation is used for sending a CDR from CPO to Hubject platform. Hubject will not only forward a CDR to online EMP, but will also store CDR in its database in case EMP system cannot be addressed at the moment. CDR data model is huge and has a lot of details regarding charging session. We won't cover them all, but we will point out the most interesting ones. Signed meter values is a custom field needed in order to be compliant with German market regulations. Another field needed for that regulations is calibration low verification info. This field contains additional information regarding signed meter values. Charging start and charging end are pretty self-explanatory, but how they are different from session start and session end. In general, session can be started before charging process. For example, when user authenticates himself at the charging point by RFID card. Also, session can end after a charging process is finished. Because of that, Hubject introduced separate fields for start date and end date of those two concepts. Consumed energy is a difference between meter value end and meter value start. Each of these fields is expressed in kilowatt hours. Meter values in between is a list of meter values present in charging session. It is used for showing more detailed characteristic of a charging. Another service offered by Hubject is eRoamingReservation. This service is very simple. It contains only two operations. Implementation is not mandatory by CPO, but if charging station offers reservation services, then this functionality can be exposed to EMP by using operations defined in eRoamingReservation service. First operation is eRoamingAuthorizeRemoteReservationStart. It allows EMP customers to reserve a charging point of a CPO. Information if charging point offers reservation services is a part of an EVSE data in Value Added Services field. Hubject will first check if there is a valid contract between EMP and CPO, then it will check if EVSE is known and if CPO is the owner of EVSE, and after that it will forward the request to CPO. As a result, session ID is generated, and also we must remember that provider ID and EVSE ID must be a part of a request. Request for AuthorizeRemoteReservationStart is very similar to AuthorizeRemoteStart. We have an identification field, which holds authentication data to authorize the user. Also, we have previously mentioned provider ID and EVSE ID fields, which are mandatory. Then we have a duration field, which is expressed in minutes. Finally, we have session ID related fields. If we have a possibility to start reservation, we also need to have a possibility to stop reservation. eRoamingAuthorizeRemoteReservationStop is used for that. It's very simple. It allows EMP customers to end existing reservation. After that, CPO must generate a proper CDR for this operation. Request for remote reservation stop is very simple. You must provide session ID, provider ID, and of course EVSE ID.